To get started, it's my great pleasure to introduce a good friend of mine from the physics department at University of San Diego, the other university here. Well, actually, there's three, I guess. He's also a decathlete. Where you 10 events over 3 days is quite fit. Gentlemen, Daniel Sheehan, who will talk about time and consciousness. Daniel.
Good morning. I'd like to acknowledge a few people, Patricia Cyrus and Crystal Ibarra. My interest in consciousness and time probably goes back to college, but almost 35 to 40 years ago, but there really wasn't a venue to talk about these things in any kind of safe way until Toward the Science of Consciousness was started about 20 or more years ago by Stuart. So I want to thank him especially for making a place where I think hundreds, if not thousands, of researchers have now begun to talk about this subject seriously. I think two of the most irreducible and undeniable aspects of our existence are time and consciousness. Consciousness unfolds in time, and you really can't perceive time without consciousness. So even if you were to close your eyes and imagine a world empty of everything else, you would still be able to affirm your own consciousness and the passage of time. So these two quantities are perhaps the most primitive things of our existence, and yet these are two of the things that are probably the most inscrutable. Certainly consciousness is. I've been coming to these meetings for over 20 years, and I still haven't heard a definition for the quantity yet. And as far as time, well, time is beginning to unravel in physics. It will probably be the subject of maybe the next revolution in physics because there is no consensus about what it is, whether it is absolute or emergent, whether it flows forward and backward. There are many questions. And so what I'd like to do today is talk about two things, one associated with time, one associated with consciousness. Both are on the forefront of both fields, if you wish, or at the fringe, depending on how you want to look at it. But they're related to each other. The first is retro-causation, which I'll explain shortly, and the other many of you have heard of is precognition. Now, if we can understand these two things, I think retro-causation and precognition together, we might begin to get a handle on some of the more interesting aspects of consciousness and time. For instance, is mind and consciousness classical in nature or perhaps partially quantum in nature? Is time unidirectional as we experience it, or is it in fact bidirectional? Are the laws of physics, are they time symmetric or symmetric? Again, in physics we look at forward time solutions to problems, but are there reverse time solutions that are also physically reasonable? As discussed by Yvette yesterday, there is probably a number of new technologies that will be developed as a result of understanding consciousness, general relativity, time, and so on, and in computing. Especially with computing either being classical as it is today or quantum computing, which is coming on the horizon. There is a researcher, for instance, Giuseppe Casagnoli, who has shown in recent years that the quantum speedup, which is associated with quantum algorithms, can be explained in terms of partial time reverse solutions to the problem. And finally, the nature of reality itself. There are many different views of reality. I myself am a dualist, but at the extremes, some people believe that consciousness is an epiphenomena of the material world, and they would be materialists, let's say. Others would believe that the world comes from our thoughts itself, or that thought is the most primitive, in which case that would be idealism. So I think if we understand precognition and retrocausation, we might get at least some inkling about the direction of these. So let's begin with causation. All of us experience this. In causation, the past influences the present, and which influences the future. But there's the other possibility of retrocausation, where the future might influence the present and the past as well. Or they may both be operating simultaneously, in which case you'd have an epicausal reality. Precognition, which is the anomalous knowledge of future events, it goes by many names, depending on the time frame in which it operates and how it's done. For instance, presentiment for short time scales, premonition for longer time scales, and certain kinds of remote viewing. Despite what the mainstream scientific community may assert, there is very good experimental evidence for precognition. And reasons why it is not well accepted, I think, are somewhat legitimate reasons. There's inadequate physical theory for it currently. It involves human subjects, and as a physicist, one of the reasons I got into physics rather than biology is because I don't like dealing with living things. And human subjects make it difficult for many reasons, including the multi-parameter aspect of human beings. There's a lot of historical baggage associated with precognition, words like paranormal, psi, ESP, but they're only words. And finally, as Rogers pointed out quite well, science is also subject to fashion, faith, and many other four-letter words you might think of. For instance, fad. Roger came up with foolishness yesterday. I would also include fundamentalism in that list. Now, the fundamental physical laws are fairly limited. We have ones in the classical regime, like Newton's law, Maxwell's equations, which deal with electrodynamics, general relativity, and quantum mechanics. But it turns out that all of these laws have two kinds of solutions, ones that go forward in time, positive time solutions, and also the negative time solutions. Typically, the negative time solutions, which are called advanced solutions, are thrown out. But you can kind of put a point on this by considering a simple problem. Let's say we take a look at a ball rolling down a hill. At the present moment, it's in the middle of the hill. And so you could ask yourself, how do you figure out how it got there? Well, you can go into the past and calculate the equations, Newton's laws, subject to gravity, in the time forward direction and say that the past gives rise to the present. But equally well, you could look at its future state and run time in the negative direction and also solve for its present position. So if you believe in causation or retrocausation, does the present state, is it determined by the past or is it determined by the future? And the answer is yes, it's both. Both of these are equally valid ways of looking at the present. But in fact, in our everyday experience, there are both reversible and irreversible processes. So for instance, if you take a ball and bounce it off a surface like this, if you reverse its direction, it looks perfectly reasonable. So that's time forward, here's time reversed, and if you were to be shown a movie of this, you wouldn't know the difference. But on the other hand, if we bounce it this way, then it's irreversible. So you have certain irreversible processes in nature. And if you take something like a piece of paper and tear it, that's an irreversible process too. You can't undo the tearing of the paper. And even if you were to undo that, you couldn't undo the sound waves that have emanated away and damped out on the walls. And even then, if you continue to tear it up and throw the confetti in the air, there's no way to calculate where these are going to end up, at least because of chaos theory. And at the very least, this process will never reverse and land back in my hand. So you have certain irreversible processes in nature. And these are both in classical and quantum realms. So irreversibility in the classical world we belong to is due to the second law of thermodynamics, which is a statement that the entropy of the universe never decreases. In other words, the disorder of the universe continually rises in general, and work goes into heat, and you can't redeem that. And the second is in the quantum realm. We have wave function collapse, or if you wish, decoherence, where the coherence of a quantum system gets exported into the environment in an irreversible fashion, somewhat like the second law. So these define what are called the arrows of time. And there are many arrows that have been acknowledged, the cosmological arrow associated with the expansion of the universe, wave function collapse, the second law. And we also have our own psychological arrow, which probably conditions our experience of all the rest. So I'd like to turn now to how we look at the arrows of time in terms of quantum mechanics, which in principle governs the physical world from the lowest to the highest ultimately. And there are many different versions of quantum mechanics. When I say versions, I'm talking about interpretations. So you can have the same formalism, in other words, the same mathematics for all of these, but the ontology behind the mathematics, the physical meaning behind the mathematics is different in these interpretations. And you have a number of different ones. But some of these actually allow for retrocausal behavior. In other words, future events influencing the past, or at least integral to that. And these go back almost 70 years. The one that I find most appealing is what's called the transactional interpretation developed by John Kramer, at the University of Washington in 1986, which is based on work done in electrodynamics by John Wheeler and Richard Feynman back in the 1940s. And in this particular transactional interpretation, the wave function is ontologically real. It is a real quantity. In normal Copenhagen quantum mechanics, it is not. It is simply a mathematical object used to calculate physical properties. It does not have any reality to it per se. In the transactional interpretation, one can define a retarded wave. This is one that travels from the past into the future, and this would be given by psi, which is the standard wave function, and given by the ket. There's also an advanced wave, which comes from the future into the past, and it would be considered the complex conjugate of psi or the bra. These two together interact and handshake to create the present. And it turns out that the transactional interpretation is quite powerful, because what it does and is able to do is to resolve many of the most pernicious and famous, all of them in fact, paradoxes in quantum mechanics, including the Einstein-Podolsky-Rosen EPR paradox, Wheeler's delayed choice, and many others. It is relativistically invariant. And it gives very natural interpretations to things which are normally just considered ad hoc. For instance, the probability density, or ways of calculating the average, the expectation values for an operator, which includes both the time forward and time reverse solutions coming together to create reality in the moment. So for instance, if you wanted to describe just doing something as simple as seeing a star at night, you could explain it in the transactional interpretation in the following way. So consider the red giant Betelgeuse in the constellation Orion. Betelgeuse is the red star in the shoulder of Orion, and it's about 520, 525 light years away. So the way in which the transactional interpretation would work would be the following. 520 years ago, back in about 1495, the star Betelgeuse would send out an offer wave. This would be the retarded wave, psi, which would go in all directions, that particular photon, so to speak, and eventually, years later, follow the light cone. This is a space-time diagram with time and space on the two axes. And after 500 years would reach where we are, or your eye, and at that point, if a decision could be made to send back a response wave, this would be the advance wave back to the star backward in time, and there would be a transaction possible here. And by stochastic choice, if this handshake was agreed upon, there would be a repetition of these until conserved quantities are agreed upon, energy, momentum, and so on. And at that point, bing, you would see the star. And so you actually have an interaction between something in the past and something in the future, and vice versa, in order to create present-day reality. This is the handshake. Now, I'd like to change directions again to experiments in retrocausation. There have been experiments for 40 or 50 years which have been very convincing in terms of demonstrating retrocausation, both in standard laboratories and ones with human subjects. Probably the most famous in recent years is the ones by Daryl Bem, in which he conducted a series of 9 experiments on college students, which showed clear evidence of retrocausal behavior. One in particular which I'd like to kind of point to is one which was reported on in 2016 at a conference on retrocausation at the University of San Diego, done by Graf and Cyrus. In this experiment, you would have a remote viewer or a viewer who would, on Saturday evening, try to find out what would be published on page A6 of the Reading Eagle on Tuesday morning. And on the bottom of page A6 is an international photo taken from the AP files, of which there are hundreds. And that photograph would correspond to a world event that occurred during that last day. And the photograph was not taken until Monday. And it wasn't decided to be put in the paper until about midnight of Monday so that it would appear on Tuesday. And yet, the point of this experiment was to find out the preceding Saturday what that picture would be. Now, in a set of 33 trials, they had roughly 2/3 of them, they were able to get enough information to actually pinpoint what that photo would be well enough that judges were able to discern that that picture corresponded, or their impression of that picture corresponded to the actual picture. And the details of that can be found in these proceedings. But one can apparently look into the future. But what does that really mean? Is the future coming back? What part of the future is coming back? Are we going forward into the future? There are various questions and ways of looking at this. Now, the timescales of retrocausation that have been demonstrated go all the way from the shortest timescales that can be measured down at the level of elementary processes, like Compton scattering, all the way up to things like premonition on the order of 10 to the 7th seconds. So they span in logarithmic space a fair fraction of the examined timescales of the universe. Now, retrocausation cannot be a classical quantity, at least as I understand it. It must be a quantum phenomenon because only quantum mechanics allows for retrocausation. Classical mechanics hides any kind of retrocausal behavior behind the veil of the second law. Precognition, is it based on quantum consciousness? Well, I think you can make a prima facie case for that insofar as if precognition is real and it is based on retrocausation, which can only be quantum in nature, then there must be probably some aspect of consciousness that is quantum mechanical. So, can the brain be quantum mechanical? Well, at the microscopic level, it certainly is when you look at atoms and molecules, because you can't understand them, at least in the modern paradigm, without invoking quantum mechanics. At the mesoscopic level, in terms of microtubules and synapses, there have been a number of interesting theories that have been put forward that would suggest that, yes, it is quantum mechanical at that level. Work by Hameroff and Penrose would point that way. At the level of macroscopic, neuronal assemblies in the brain, that's an open question. But I think just the evidence of precognition would somewhat argue for that. I'm going to skip these and make an interim summary, which is that the physical laws as we know them are temporally symmetric. That means when you look at the way they're stated, there should be forward and reverse solutions. Classical reality, though, is asymmetric, probably because of the second law. Some quantum models, however, are temporally symmetric and would allow for retrocausation. And the experimental support for retrocausation seems to be very strong. And some brain processes could possibly involve quantum mechanics. So I'd like to put forward the following hypothesis and explore it. I believe that the most parsimonious and probably correct explanation for precognition as it's currently being seen is that, at least in part, it is caused by retrocausal influences between the observer, that means the person experiencing precognition, between their future and present self. It is not the universe itself which is coming back, or they're not going into the entire universe to get information. The information is already contained in the observer themselves, and they're simply communicating through time, not through space. But to do this, they have to contend with two things. The first is the veil of the second law. And by that I mean, when the second law, in a sense, is a way the universe forgets. For instance, my voice, when I speak, bounces off the walls and is damped. If that were not so, it would keep ringing through this room, and all your heartbeats and your breaths and your words would continue to ring through this room forever, and it would get noisier and noisier. But it doesn't. All of this goes into heat eventually. And as a result, there is this forgetting that goes on because of the second law. And the second law itself occurs because of the low entropy state of the original universe, which allows the number of microstates, omega, for the universe to continually to increase at an exponential rate. This is basically a restatement of Boltzmann entropy. So if one looks at let's say, a person in the present in a particular physical state, because of the increase in the number of ways in which the universe can proceed in the forward direction, if one looks at, for instance, the transactional interpretation, there are many more ways for it to interact in the future than into the past, exponentially more, astronomically more ways. And as a result, the present tends to proceed into the future. There is also the veil of the wave function collapse in quantum mechanics. If you wish, another way to think about it is decoherence. So are thoughts quantum in nature? Well, I would argue that very likely they are, and at least some of them are. And if you were to look at the brain and look at a particular set of let's say neurons, which are assembled to think of a particular face, let's say Stewart's face. I wouldn't recommend that, but let's say Stewart's face. Then that particular arrangement of neurons are basically unique in the universe. I mean, the brain itself is possibly the most complex object in the universe, but the particular set of neural assemblies associated with your particular version of Stewart is probably unique in the universe as well. Now, there's high specificity here. In the future, let's say that in some future state, 5 years from now, when you haven't thought about Stewart in quite a while, suddenly, for some reason, you think of him. Well, under those circumstances, an advance offer wave would be sent forward in time, and an advance wave would be sent back in time, and there could be a response wave being sent forward, but there's nothing to intercept this particular unique set of quantum mechanical assembly going forward and backward in time, except itself, in which case you would have a means by which to have a retrocausal event which circumvents the veil of the second law. So I would argue then that that precognition is the result of a quantum process that is within the realm of standard quantum mechanics that allows for the future to communicate with the past and vice versa. But I would also say then that if that is a materially based process, then it should be possible to make a retrocausal oracle. And what I would argue, this would be an apparatus for precognition. It would be an object or a device which would be able to communicate with its own future or vice versa, and something that could communicate with its past. If you were to, for instance, have random numbers put into this device, let's say 21 random digits and 1,000 times per second. With 21 digits coming in at 1,000 times per second, and if they were all random, it would take the age of the universe before you'd see any repetition here. So for instance, if you were to have some sort of random number generator inputting into a device in the future, and for some reason you actually get that same set of numbers in the past, maybe a few seconds or a day, whatever it happens to be, that would be evidence for retrocausal behavior or a precognitive oracle. This oracle would have to have certain characteristics. First, I believe it would have to be purely quantum mechanical, such that you could have this retrocorrelation or retrocausation operating. It would have to be isolated from decoherence so that its quantum nature would be undisturbed. And this could be done by having it so complex as the human brain, for instance, that it might be in some sort of a decoherence-free subspace in Hilbert space. And it should be complex enough, of course, to be highly specific, and its wave function would only be subject to self-interaction. So I'd like to lay this down as a challenge, that the scientific community should do something which sounds impossible, which is to create an oracle, to create a retrocausal oracle. And if one were able to do that, I think it would have some bearing on what we're trying to achieve in our enterprise here, which is to understand whether consciousness is classical or quantum. And it would probably then, if it were successful, would argue for a quantum form of consciousness or a quantum form of processes in the brain. It would also help settle the question about the unidirectionality or bidirectionality of time. It would also help establish physical laws as being time symmetric as they are on paper, and it would probably give rise not only to new quantum technologies, but things like quantum computing as well, and also would help us understand our material or idealistic world. Thank you.
Thank you, Daniel, for a great talk, as I knew it would be in advance. Questions?
I'm sorry if I missed the beginning of your talk, and you might have mentioned David Bohm, but I gather from your abstract...
Could you speak up, please?
We can't quite hear you.
I missed the beginning. I'm sorry, but I gathered from your... If you mentioned David Bohm, I'm sorry that I'm bringing this up, but your abstract clearly said the conscious observer has been part of the quantum theory since the start. Well, in the 1950s, David Bohm provided an alternative deterministic version of quantum theory that doesn't include the observer, People objected at the time for reasons that it embraced non-locality. Well, non-locality is everywhere these days.
Yeah.
So I just wonder if you could comment on that.
I was interested in Bohm about 20 years ago, and certainly his particular interpretation of quantum mechanics has advantages in preserving things like real particles, but it does so at a price of creating the pilot wave, which is, in a sense, a quantum field. And so ultimately, I kind of moved away from that, but I wouldn't necessarily discourage people from trying different interpretations of quantum mechanics. All valid interpretations of quantum mechanics have to give the same physical results, or at least they have to comport the same way with the physical world. If they don't, then they're not a valid interpretation. So all of the interpretations can accommodate the physical world, but and so in some sense, whether you're a Bohmian or a Kramer, or you do a Copenhagen or whatever, that's a matter of taste and aesthetics. But on the other hand, certain ones I think are more revealing and give better interpretations for how the world works, or at least more appealing ones. And so I've kind of settled on the Kramer approach, particularly because it explicitly invokes time reverse solutions.
Okay, thank you. It was a very good talk. Hello. I want to ask you one thing, that what exactly happens to free will when you talk of retro-causation in terms of consciousness?
I'm sorry, what happens to what?
What happens to free will? Okay? Free will.
Well,
Okay.
I suppose if there's an agreement between what you decide to do in the present and the future, then I don't see that necessarily destroys free will, it just extends it in time. I don't see it as a problem.
Can I make a comment on that? Because classical neuroscience say that the processes in our brain happen after we respond, that makes consciousness epiphenomenal. However, if you have backward time effects, that allows consciousness, the activity to go backward in time so that you can act consciously even though your brain hasn't processed the activity yet. So actually, backward time effects could rescue free will. This lady here. Daniel, are you bothered by, we've talked about this before, saying retrocausal, since in the Alice Bob quantum information, supposedly there's no causal effect, it's correlation?
Yeah, there's always been, I mean, in the last 100 years or so, I think there's been kind of a consensus among a lot of philosophers, and I think among some physicists, that causation is kind of an outdated idea. I don't really believe in causation, I believe in strong correlations. So if I do something like drop this ball, I can expect it to fall, but I can't see the cause of it. It could be falling because I'm pushing it, it could be falling because of gravity, it could be falling because of electrostatic effects. You can't see causes. You invent them to explain things. So what you do see is correlations. When I open my fingers, the ball falls. And if I can do that many, many times, and if I do it a million times to the point where that correlation is so strong, then I want to make a story for why it's that way. And that's where causes come from, at least I think in general. So technically speaking, you're right. I would say that I think retrocorrelative would probably be a better term, and I myself don't believe in pure causation or retrocausation. I think really strong correlations are a way to look at it.
Can there be effects on quantum processes that have already collapsed, or can it only affect things that haven't collapsed yet?
Well, a correlation is simply one event being somehow related to another. But of course, before it happens, there are many possibilities for what could happen. So yeah, it's certainly probabilistic, at least as we currently understand it. Yeah.
Please be brief, we're running out of time.
My question has to do with what you were talking about when you were talking about quantum input to specific brain states. And I'm wondering if you've looked at dreaming, specifically REM, and lucid dreaming, which is a half-awake state. Mm-hmm. Both of these are well characterized. They have, there already may be data on, brain states, specific brain states. And it wasn't clear to me whether or not you had included that in the example you gave us.
Well, if your dream occurs in the physical world, which I presume it does, then I guess it would be fair game for this. Sure.
Two more questions, Tatiana, right there, and then we'll go to Steve.
Yeah, I still did not understand. Did you overcome second law or not?
Sorry.
You told about second law of thermodynamics as a main setback for retrocausation. Did you find a way how to overcome second law?
Second law.
Second law, yeah.
Overcome the second law.
So in terms of the second law, in terms of retrocausation?
Yeah, you
Yeah.
told about second law, but I didn't understand.
Well, the second law is in fact, I'm glad you brought that up. The second law, in fact, is a stand-in. It's a probabilistic law. I mean, it has an inequality associated with it, and it's based on the number of microstates that are possible let's say, in a future state versus a past state. And so just based on probability, you expect things to evolve into a more complex set of possibilities. But on the other hand, if you had a retrocausal process, let's say, that reached back in time, that would trigger, let's say, a quantum event, let's say in your brain, that would trigger a cascade of ions flowing across synapses and the use of lots of glucose in your brain. In other words, the creation of lots of disorder, chemical reactions. But I don't see any reason why the second law can't work backward in time as long as the number of states going back in time is large enough that it would be favored or at least comparable to what is in the future. So I see no problem with that. Second law should be bidirectional in a sense, and I don't think people have really recognized that before.
Let me say that I hear from a lot of neuroscientists that they see this effect in their experiments. They see the response before the stimulus, but they won't talk about it in public. I've heard that from many neuroscientists.
You had earlier commented that there was empirical support for precognition. On the other hand, all the studies I've looked at debunk those claims. Could you give us one example of precognition that has not been debunked?
Well, when it comes to experiments in general, I think if you've been reading, I think it's Science and Nature, they've been reporting on more replication experiments. And it turns out many experiments, if not most, are very difficult to repeat. The only experiment that I've ever seen everyone repeat well is this, dropping something. Other than that, you can have lots of people do the same experiment and get no results simply because they have, simply because they have not done it well. And when you look at people who have done, let's say, failed experiments like Alcott and Wiseman and so on, these are skeptics who actually have good reason not to do it well.
But what would be one phenomenon you feel has been demonstrated?
I think presentiment as well is well documented, and I do think that the future remote viewing is well documented as well.
Daryl Bem's
Yeah, Daryl Bem's entire spectrum as well. I mean, there are plenty of experiments which demonstrate it. I'd be happy to share with you a list of readings if you'd like to look at it. Julia Mossbridge has done very nice work. Dean Radin, Dick Bierman, and so on. So there's lots of experiments that are well done. And in fact, I would say the experimental protocols for those exceed the stringency of virtually any scientific protocol you will find, such to the point that even skeptics can really find no real loopholes in the experiment and simply say that they're wrong without any real basis. So this is, again, has to do with, I believe, fashion, faith, and fundamentalism in science.
Okay, thank you. Let's give Daniel a nice round of applause. Another friend of mine, Dr. Peter Fenwick from University College London, who will speak on neural sources underlying meditation-induced transmission of light. Peter.
Thanks very much. I too would like to thank Stuart for the Consciousness Symposia. When I was at college, I had 2 Nobel Prize winners in my college. One was Lord Adrian, and he discovered the algorithm. And of course, my supervisor was Huxley, of the Huxley-Hodgkins equations. But none of those people, and it wasn't even fashionable to talk about it, consciousness was left out. Levels of awareness, yes, consciousness, no. So it's really a great pleasure to be at a symposium devoted entirely to consciousness. But not only that, Stuart very kindly, and the committee have asked me here, on June the 9th. So why June the 9th? It's my wife's birthday, so we can celebrate it here. So what I want to do then is talk about light. There's a long history of association with meditation, spiritual experiences, and death. And I'll go into that just a little bit. We're all into contemporaneous accounts at the moment. And this is one, because this is on the sarcophagus of St. Francis at Assisi. It was painted really quite close to his death. And there are the monks seeing St. Francis riding in a chariot of light across the sky when he was meditating. Goodness knows what they really saw. There's a long tradition of mystics and light, and one's used to having halos around people. And of course, it's halos, lots of halos. That could be just artistic culture, but in fact, it probably comes from the fact that people can see light. And I've chosen you a Buddhist picture just to show you that it's still going on today. Now, there's an editorial which was published in Frontiers, which says, what can neuroscience learn from contemplative practices? And so that's really where we're going. One of the more important experiments was the phenomena of meditation-induced light experiences. These are in the people who are meditating. It was a qualitative study, 24, and various Buddhist meditations were used. And half of the people were very experienced meditation teachers because they were, in fact, had a long history behind them. And here's just an example. I was bursting with light. I would just close my eyes and it was just brilliant light. I just felt like I was radiating, like there were rays of light coming out of me. It felt like it was just emanating from my body and my system. But this wasn't my entire retreat by any means. It was a part of it. Now, I'd like to ask you, how many of you have experienced light in meditation? Wow, just look at that. Okay, how many of you have seen light in other people in your retreats? Well, far fewer, but there are enough of you to show that it's quite a wide-ranging phenomenon. So the summary of that report, the majority reported experienced light or other forms of luminous experiences. Light experiences are two broad types, and please do remember this. Discrete light forms, globes, jewels, spots, or stars, these migrate through your consciousness, and patterned and diffuse lights shimmering with pixelation. Now, there are other situations where light is important. Communication with the perception of light in the NDE, go down the tunnel and you see a light which is very bright and doesn't hurt the eyes. So it's seen in that sort of experience. Now, it's seen with dying people. I got a lot of data on that. Radiant light in the room of the dying. White light surrounding the patients as they died. Really interesting. Transfiguring light over the patient, either white or gold. Globules of light in the room, we come back to that again at the time of death. And sources of light, not electric light, but these go out when the patient takes their last breath. So the light and dying, light and transcendent experiences are all linked together. Now, the first neuroscientific study that I can find of light experience during meditation is this Chinese one in 2003. And it's a Zen Buddhism experiment. And the person who was meditating was able to stop his alpha rhythm when the light appeared, and you can see it there. So it's an argument for the first time that there's a correlation in the neuroscience and the experience. So it's an important pilot study investigating this phenomenological experience, blocking of alpha and an increase of higher frequencies during inner light, but provides very little information about the underlying neuronal source, and it's imprecise temporal information. There's no clear temporal markers. And there's little information about the interactive nature of light and its transmission or perception. So we'll need to go into those aspects further. Now, if you go back into the literature, you come across studies like this. This one dates from '84, and it is, I think, enormously important. It shows that the visual sensitivity changes with meditation, and this is a mindfulness meditation one. They showed that there were enhanced detection thresholds and discrimination between two flashes, so your perceptual processes had been raised to a slightly different level. And the conclusion was that the visual mechanism can become more sensitive. And this idea of a relationship, a sensitivity of the visual mechanism to the meditation process, I think is important. So the current study, the principal aim is to find and describe the neuronal sources in a meditation teacher's brain during the manifestation of light when it's seen by others. Now, we've in fact looked at the electrodes. But first of all, we need a teacher who can transmit light. And there's this guy, Alain Forget, and he's written a book, How to Get Out of This World Alive, because he's a philosopher, and he has his own system of how you can improve yourself. And I've put some books down there. They're free, so if you want them, please take one. Now, the background is really interesting. He's age 65, and he was born to a French landowning family. Traveled in his adolescence and early manhood to Australia and then returned to France. Now, he has no formal higher education, and he's a trust fund kid. Now, trust fund kids don't have to work. So he spent most of his life, to begin with, chasing girls and sitting in cathedrals. He found two esoteric teachers. One had been trained by Gurdjieff, a philosopher from the 1900s, and the other, a very interesting guy, who was picked up at the age of 7 in France by a Tibetan monk, and he went with this monk and returned later on. And he's a rather exceptional person. Now, till the age of 50, he studied the mystic texts and sat in silence in cathedrals, and he's reported to have had 2 breakthroughs or awakenings, age 26 and 39. And he developed the ability to give light energy in 1995. Well, there he is. And this is a sort of cartoon of what it's like when he gives light. In fact, it isn't like this at all. It's very difficult to produce a cartoon of what it's actually like, but you get the idea of light in the room. Some of them is colored, it surrounds him and comes off him. So what is the subjective experiences the students see? White and colored light seen surrounding him, colors on him, on hands and face, very strong light also in the room, changes in the density of the air in the room, which becomes colored, often purple. Light forms like globules or sparkles, again, we've had those come up before. And now the development of the cities and the students, and I'll just take that a little further in a moment. The other subjective feeling they have is energy being transferred from him to the students, and they describe energy entering the body, heat in the abdominal area, energy circulating up the spine, energy dissolving into blocks, dissolving blocks in its free flow through the body, and energy leading to opening of the heart. So, can everybody see it? No. About 50% of people can and 50% can't. And there's his book, and his philosophy is that we're all built on guilt. Childhood leads to a number of blockages. These blockages need to be cleared to allow the full potential of the individual to grow. And the point of the light has a clarifying, dissolving effect, and he uses the interpretation of dreams, the practicing of meditation, and attacking your fears. And you develop the cities and can awaken. Now, I want to talk about development of the cities because this is the first time I've come across a really good model that we can study independently. people in his group see colors with the light during the light giving at the start of their development. After they've been with him a little while, the colors arise spontaneously away from the light-giving sessions. And please do go back to that first study where we were talking about changes in the sensitivity of the visual system. And when dealing with people, colors arise, which helps you to understand their covert feelings. And so when the city is fully developed, you can look at people, see colors on them. That will give you some guide as to how they're feeling. Well, what about the physical features of this light? Firstly, attention enhances the perception. Soft eye focus increases the experienced brightness. It's enhanced by a brightly lit room. Well, that tells you straight away that it must be something to do with the visual system and not to do with photons coming out of him, but how can you tell until you measure it? It's attenuated by a double glazed door, and it's almost abolished by complete darkness. But note that cameras are not sensitive to this light. You don't get a picture of light surrounding him. As far as the students are concerned, they see color and light structures during the day. They wake at night to feel energy circulating through the body, and they develop a more body-centered experience to block the links with certain behaviors, and so they get changes in the way they see their psychology. There is, in fact, 100%, if we take 100% as the time, as the level of the light, when you sit face to face, you can see it transmitted over FaceTime, but FaceTime, of course, has movement, and you see a full picture. A still video, there is you get about 10% of the impression of the light that you would if you were face to face. Now, EEG hyperscanning, we did this study. It's not a properly controlled trial. It's a pilot and set up to show proof of activity. This is the lab. There's the student. There's Alan. When the messages for Alan, they're given behind the student so he can't see them. And when the messages are for the student, they're given behind Alan. So a sort of standard hyperscanning experiment. But we also included one condition where we put translucent goggles. Now, the actual format was teacher transmitting, student receiving, teacher not transmitting, student receiving, teacher transmitting, student not receiving, and student not receiving and teacher not transmitting. So we got all four of them. And then the other one where the teacher is sending, the receiver's receiving, but they're wearing the goggles. So what did we find? Well, we found this huge, abrupt rise over the parietal and temporal electrodes. This is a frequency profile up to 100 hertz. There you can see the alpha activity, and now this huge gamma activity, which goes on throughout the frequency range. Very striking, very unusual. If we look at the plotting of it on the scalp, you can see delta, theta, alpha is a bit different as you're beginning to get more activity in the temporal regions. But then as you go up into the beta, low beta, or the high beta, low gamma, and high gamma, you can see huge amounts of activity over his scalp. This is exactly the same thing, but with another student, again, huge amounts of gamma. So if we look at this, we can look at all the conditions, and the high bars there are, interestingly, the bars in which he is transmitting. These are the ones when he's not transmitting, and this is total power, and these are the conditions whether the student is receiving or not receiving. But the point is that when he's transmitting, you get huge amounts of gamma power, even when he's blocked with the goggles. And these are the different frequency ranges. That's 12, 12, then low gamma and high gamma. So there's no doubt that he's got very unusual brain activity. So there's a very large increase of high-frequency neuronal oscillations during transmission of light energy. It's more prominent in posterior, but also over other distributed brain regions. And such increases were specific to the transmission irrespective of the receiver's state. So this is something in his brain by himself. So we're going to look at this a little bit more. Now, we have done sensor linkages. This is electrode linkages. And we've looked at the phase slope index, which is a way of looking at connectivity, which brain is driving which brain at what frequencies and where. But the argument is always that this is too inaccurate to brain and scalp smearing. So what we've tried to do now is to go on and look at the actual brain itself. This is the map from the sensor study. You'll notice that the parietal association areas, fusiform gyrus, and the visual cortex are all driven. They're driven by the teacher. This is a student's brain. So it looks as if he is in some way messing with these structures. Now, you could argue that this is probably something to do with a visual communication, and indeed it must be, because if you put the goggles on, these go down. But it looks as if you're in visual communication with him, then he can affect those areas. We can get localizing information from the MRI, and this was done with light giving versus mind wandering, the sort of usual fMRI paradigm. We forecast that you would get changes in the cerebellum, which you do, in the post-central area, which you also do, and finally in the inferior temporal gyrus, which is important. So we were able to show that you do, in fact, get fMRI changes at the same time as you're getting the gamma activity. So the maps are useful but not sufficient, as the fMRI is too slow to reveal brain dynamics, and this is one of the problems. It's more a problem with me because I've worked a lot with MEG, and here, of course, you can look at the brain working at very fast speeds. So in fact, we're using a new method of source analysis. So we're going to actually look at what the sources do in the brain. We use a method called electric field tomography, and it gives a temporal resolution in milliseconds and source level representation, and there's frequency-specific information. Now, I'm not going to go into this, but if anybody is interested in it, please do note this address. It's Andy Anides. In fact, he's in Cyprus at the moment, and he will give you any data that you want on it. And if you forget the name, then just send me an email and I'll let you know. But this is a cartoon of what we do. We, in fact, take a 2D array of the cap. It could, in fact, come from an fMRI of the brain. And then we slice it into slices. And then we divide the slices into regions of interest. And then we have a time series of slices with their regions of interest. Then we calculate significant frequencies in each of the regions of interest, so we get a spectral profile of the sources. We do wavelet decomposition and summation to get a time of activity in the sources. So that's the method. So you can look at frequency and time. So what did we find in his brain? Statistical comparison between conditions showed increases in the activity while the teacher was sending across widespread areas of the brain over a wide range of frequencies, starting in the theta band to the high gamma band. Averaging of the spectra of each condition identified focal changes excuse me, in a well-defined area. Now, for the overall frequency structure and location of these sources, and this is interesting, remember that these summaries are composed of numerous short bursts of activity, which I'll show you in a moment. The sections are midline sections, cerebellum and the mid-temporal gyrus. But please note how the sources move from side to side according to the frequency. So you can't just take a frequency and think, okay, well, that tells us something about the brain. It tells you just a little bit of the information. So here are the frequencies, those are the slices, and we've mapped onto those the activity in the sources. That's nothing much. You're coming into the theta range, nothing much there. As you come up into the alpha range, you get a little bit in the cerebellum going up into the posterior temporal area. With higher frequencies, you see this interplay between cerebellar activity and posterior temporal activity. There is frontal activity, but I can't show it to you on this slide. And you can see that, in fact, it swings between hemispheres. There's a bilateral picture at 18 hertz. As you go up to 32, more up to 40 hertz, you see it's becoming much stronger and more bilateral. After 40 hertz, it starts becoming more unilateral. And at 88 hertz, it's much more right hemisphere orientated. So what one is looking at are the structures which support this gamma activity at different frequencies. So now let us go to the time domain and see how the high gamma activity evolves in the sources of the brain. Don't be surprised if these changes are transient, because the brain acts as a dynamic network and not a localized area only. And what I've got here is sections at the level of the cerebellum and the medial temporal gyrus. And this is a cartoon, well, it's not really a cartoon, yes it is, of the mapping of the actual activity. So if we think, where do I put it there? Yeah. Now you can see, just look at the brain, and you can see the flickering activity before, and now we're coming into the giving of the light, and you can see there's very much more there. If I stop it, I might be able to stop it at a place where you can see some activity, left temporal, cerebellar. And so I want you to get the idea that, in fact, we are dealing with a wide network of events which spread widely throughout the brain. And this whole is 500 milliseconds before, and it ends up at another 1500 milliseconds, so it's a 200 millisecond slice. So that's the sort of way that you need to think about activity within the sources. BA21 and Brodmann's area 21 and 37 are very active when the light starts to be given. And we show total activity over time for different areas. So this is total time. And this is, to me, enormously interesting. It's 2 seconds, that's 1 second along the bottom there. That's 0, so no light being given. And then he gives light, and you see these very, very high pulses of activity in the fusiform gyrus, and that's just a map of where we're looking. And if you look at another area, like this is BA21, you can see exactly the same. And in both these areas, you'll note that the right hemisphere shows practically nothing. It's very much confined to the left side of the brain. And the next thing we do is we decompose the signals by wavelet analysis, and then we look at total power. So we're looking at total power in frequency bands, 8 to 14, which is high alpha, low beta, then low gamma up to 45, and high gamma up to 95. And you see something else here very interesting, and that is that the frequencies behave quite differently. You get peaks of one frequency, and then you get peaks of another frequency. And again, this is where the light is given and all this activity is enhanced. So signal power of high gamma activity as the recording progresses for the three conditions for which he is sending. So now what we're looking at is we're looking at 2 minutes 20, which is really the time of giving light to the students. And this is a log scale, so this is enormously high. These are the ones taken when he's giving it. These are the ones below. So there's a huge difference. This is a second trial. There's a huge difference in power when he's giving it and not giving it. So in summary, consistent changes in his brain during or giving of light energy. These changes are also quite immediate, suggesting his ability to enter into the specific brain state at once. Now, those of you who work with meditation will know that TMers take a long time to ramp up their activity. Vipassana, Theravada meditations are much quicker. So it looks as if he's on that sort of dimension. BA in 21 and 37, the actions potentially suggest a switch from external to internal representation. So it's suggesting, in fact, that he's going into his internal world, which he describes as cosmic. The cerebellum shows focal changes, and I'm not totally clear what they're related to, possibly related to various types of cognitive processes to be looked at. So an overall summary, sensor level analysis showed an unusual brain state with excessive high-frequency oscillations, mainly over the paratotemporal regions, but also over widely distributed areas. And it's very specific to the light-giving state. So clearly, his brain is doing something very unusual. Well, can we get any evidence from the literature? This is Beauregard's fMRI study done in Canada, in Montreal. And in line with this, he says, we recently found Carmelite nuns that enhanced gamma band activity in the temporal lobe. And this was associated with a subjective impression of union with God. And so the idea then that high gamma activity, widespread like this, is in fact correlates with very wide subjective experiences, I think is becoming true. Robust and consistent changes in the brain of the teacher when giving light, and these changes are highly unusual, and exceptional states of mind are correlated with exceptional states of the brain. It's certainly true. So what's our next study? Repeat the study with proper controls for exposure to the face, eye movements, cardiac monitoring, screened room, and naive and experienced subjects, and search for any other light givers. Anybody know of people who can actually transmit light? I think there are one or two of you. So can you see me afterwards? And we can talk about light givers. So, what do we take from this? Well, studies of hyperscanning now are enormously important. You get increases in children when attending in class. There's more linking of rhythms between them. In adults, when linked emotionally in a group, you can see the significance of this in the EEG frequencies. And many of you will have seen Michael Spivey's talk of group linkage in adults, and this is enormously exciting and important, because we have this idea that when we go out into social situations, we link the frequencies in our brain. And now we're coming on to another range of studies, which are those of Jacobo Grinberg. Jacobo Grinberg was a Mexican, and he argued that if you put two people in the same room, they in some way entangle. So he did this, got them to meditate together, got people who were emotionally close. And then he separated them, and he put electrodes on one of the pair in one room, and in another room, he flashed them with light flashes. And he measured the response of this in the other room. Now, it's called the Jacobo-Grinberg effect, and what is true is that, in fact, there are 2 or 3 studies where you can do it, but it's a parapsychological experiment, so you're going to get a lot of operator effects on whether you see it or not. But now we're moving from straight hyperscanning measurement into more remote hyperscanning measurements, and this is the sort of area which we'll be going into. So, thank you very much for your attention.
Thank you, Peter. We have time for questions. Did you talk about the receiver? The receiver? Yeah.
Thank you, Peter. I saw not light, but I saw 3 angels in the room when my mother passed away that night on hospital. I saw 3 angels, and they were so real. So when I want to go to bed on 2 chairs, but there were angels in the way for me, so I couldn't. But when my mother has passed away, I went at home again in my car, and I feel the smell of her. The smell. My mother was with me at home, or her soul. What do you think about it, Peter? Do you understand?
Ingrid, we're having trouble understanding it. There's an echo here.
Yeah?
Just give us a...
echo. Three angels. Three angels. I saw three angels. Three angels.
What, angels?
Yeah.
Angels? Okay. She saw 3 angels. Her mother passed away, and then she returned home and had an experience of smelling your mother's presence. Even though her mother wasn't present and was deceased.
So her mother passed away, and
She saw 3 angels.
in the room. Yes, in the light. Now, this is really interesting because I've collected a lot of accounts of what happens when people die. And a lot depends on the culture. In our culture, we don't see many angels, but light is certainly there. And so the fact that you saw angels is really in line with what happens. Thank you.
And the smell, when I went at home in the car, I feel the smell of my mother. Was she with me at home? Her soul, or...
Yes, you're coming into a very interesting area. And this is the idea of deathbed visits, deathbed coincidence, they're called. And this is when the dying person appears to somebody else at the time of death. And again, we've got a lot of accounts of that, and they're very specific, and it depends on the mental state of the person who gets the visit. If they're asleep, it's of one type, pushes, sometimes a voice, but also an overwhelming emotion. If, on the other hand, they're asleep, then it's a narrative dream. So, yeah, these are interesting experiences which need to be sorted out.
Thank you.
Thank you.
Dr. Fenwick here. Were there any studies or attempt to study the mental and emotional states of the students after exposure to this light or after repeated exposure to the lights? Were there any changes to their overall mental well-being and so on?
Did you get
Changes to the students who were receiving lights
After the experience.
after the experience?
What did they receive?
Are there any changes in the students?
Oh gosh, yes. I was describing to you the way the cities develop in the students, and that is one change. Another change is that they will feel energy flowing through their body at night time. And the other point is that they become much clearer in their perception of people and much clearer of their understandings of their own difficulties. So yes, there are changes.
Over here.
Hi, yes. One of the other light experience that light experiences that we hear reported is flashes of inspiration. So when people are creative, they'll get a visual flash. Some people will just kind of get an aha moment. Some people actually get a visual light-based flash. That's certainly what I get. Have you studied that at all?
Flashes of light with inspiration. Aha moments.
Oh, yeah. I'm absolutely certain of that, yes, I think there are. Because if you go into the mystical literature, there's a very strong correlation between mystical experiences and light, and between special mental states and light. It's very common, and we don't talk about it, but studies which look at that sort of area do report light, yeah.
The gentleman was up for, let him go and then you can go. Oh, okay, sorry.
Okay, I wanted to thank you for what you're doing for near-death experiences and exceptional human experiences. I have a question related to so-called phenomena of orbs, circles of light caught on digital camera. Do you have any explanation for that? Or is that just...
Yeah, auras. I was always very skeptical about auras. Certainly people around me could see auras. I never saw one. The first time I saw an aura was when Forget was giving light. Then I saw a blue aura around him. So that's the first aura I ever saw. And there is, of course, a long history of auras and what they are. And one of the early experiments I was brought up on was the one where the medium who can see auras will tell you there's a wonderful aura around that person. So you put a screen there, and they slowly move behind the screen, and they say, yeah, the medium's gone, the person's gone, I can still see the aura, I can still see the aura, I can still see the aura's gone. Then you reverse the process, and so they can't see what the person is doing. The aura doesn't come until the person arrives. And so that would argue that the aura, in fact, is not an independent phenomena, but is phenomena which is linked to your vision of the person. So I think there's a lot more work to do on this.
My question was also referring to orbs, which are caught, the circles,
okay.
the circles of light that are caught on digital cameras or on film, which I have done.
Yes, two things about orbs of light, particularly orbs on films. I'm very unconvinced by orbs on films, although some of them tend to be a bit more persuasive than others. And dust on lens and things, I think, accounts for some of them. But orbs of light is the way that these elements of light are seen as your visual system becomes more sensitive to light. And the people who I've seen going along that path, they see sparkles of light, they see little light forms in front of them, and they see colors. So yes, it does seem to be there. So I think if somebody can do a nice study on that, it'd be really good. But I've certainly seen it.
Yeah, I'd like to suggest that this phenomenon of light is not something that's just associated with meditation. When you have an 8-year-old child who says to you, Mommy, you know that light around people that changes color, what does that mean? So I showed her a book by Barbara Brennan that, different moods. If you think about it, when you measure an EEG, you're measuring a frequency, and it's on the outside of the body. Color is frequency, right? So one time after this happened, I came home from work, had my back to her cooking, and she was doing her homework at the table, and she looked at me and she said, Mommy, what's the matter? And I said, what do you mean? She said, your light is all red. Something had happened at work and I was angry. So I talked to a psychiatrist friend of mine who'd actually learned to see these auras, and he said it's just a question of, blurring your vision. And he was trying to tell me how to do it. I couldn't do it. But then I started seeing it too. I started seeing colors around people. So I think if you can measure frequencies like skin conductance and EEG, light is frequency. It's not just something that's associated with meditation, although it may change during meditation.
Thank you.
I have a related question. You didn't see any visible light. You measured these low-frequency phenomena in the brain. Has anyone looked to see if there are signals that are at intermediate frequencies, microwave frequencies? For example, the frequencies that Stewart identifies as resonant frequencies in microtubules. Has anyone instrumented to look for that? Because there must be some channel between the giver and the receiver of light, but it doesn't have to be in the visible spectrum. It could be in another part of the frequency spectrum, electromagnetic frequency spectrum.
Any microwave or radio frequency or any other frequency?
Absolutely. This is exactly where we're at now. Now that we've got somebody who can reliably produce this light in people, the first thing is it photons of different frequencies, which we're actually seeing, which don't affect the camera. It's a very real one, and Eric Virez is looking at photons being given, and I'd love to put this guy in Eric's lab and see if photons of different frequencies are coming out. And then that would go in very nicely with this idea of changes in the sensitivity of the visual system, so that it sees these other frequencies, which normally it doesn't. So the whole thing would come together very nicely then. But these experiments are waiting to be done.
Three more, please be brief. We're running late.
Yeah,
Three
sure.
more questions.
Yeah, this is very intriguing what your findings are, because I have a relativistic model of the matter, mind, and consciousness that not only predicts the physical universe, but also predicts that the extreme meditative state, the state of the mind becomes light. So that would be a very strong theoretical vindication of what you are finding in these experiments.
Explanation. Just say thank you.
All right. Thank you.
Thank you. Yeah, him, then him. Okay. Dave, then Paul.
I just wanted to bring to attention some recent work from the terahertz sensing literature. Our lab at Wright State has been doing dermal imaging, and another laboratory recently identified that human sweat glands are helical and may be acting as a metamaterial, as an antenna in the 200 gigahertz range. So this could potentially allow for linking between optical reception and transmission between the gamma emissions in the brain and the skin. So suggestion again to look in the skin of the sender in those specific frequency ranges.
Let's get evidence for gigahertz. Just say thank you. Yeah. Last question here.
Okay. So, well, thank you very much. So, with starting with meditation might give us a sense that we deal with complex metaphysical processes, but in some sense you also bring it down to forms of brain dynamics. So, would you go along with an interpretation in terms of attentional processing, top-down modulation, of, in this case, let's say color processing tied to the stimuli you're exposed? Would you be happy with that explanation of these phenomena? Or would you say they're besides the point that they miss a really key feature of it? Explanation of these phenomena in terms of top-down attentional regulation. Is that enough?
Yeah, no, I got the question. I think that's a really interesting question. In fact, if we irradiate or get a brain to irradiate itself with gamma activity up to, say, 800 hertz, will we automatically start to experience mystical experiences? Or is it that the culture of the situation enforces this explanation of what the person feels? Well, I would have been for the second explanation, but having gone to some of the brain stimulation workshops, I think we're moving slowly out of that phase now, and the ability to drive the brain externally and produce these experiences would make me think it's got a much more bottom-up feel to it than it has top-down.
Could I add just a couple of facts? In my plenary yesterday, I pointed out how just when you focus spatial attention, that in itself can enhance brightness. But an intense focus of spatial attention, which would correlate with high gamma, can actually cause self-luminosity. It's just something to keep in mind. And this has already been modeled, so maybe we could talk about it.
Yeah.
Thank you. Let's
Thanks
thank
very
Peter and wish
Thank you.
happy birthday to Mrs. Fenwick. Thank you, Peter. So I'm very pleased to introduce our next speaker. He is Dr. Lakhmir Chawla from Department of Medicine, Intensive Care and Nephrology at the VA in Washington, D.C., speaking on surges of EEG activity at the end of life. Dr. Chawla.
Thank you, Stuart. And as they say, now for something completely different. And so I'm going to tell you a little story about the data that we have generated as a consequence of my practice as an ICU physician. Now, one of the things that happens in the operating room, and Stuart's an anesthesiologist, and I want to thank him in advance for putting this entire meeting together and the ability for us to have the dialogue in a similar practice, is there's a thing known as intraoperative awareness. Now, what happens is if you have to have an operation, we do a few things. And the three things that we do for almost everybody is we paralyze you with a curare-like drug so that you don't move, because moving during the operation is not good for the surgeon. We put you to sleep with usually some sort of amnestic, and that is usually in the form of propofol or a benzodiazepine like Valium is a good example. And we give you a narcotic to take the pain away, because even if you're asleep and you're paralyzed, you can still feel pain, and that's not good. So all three of these things need to be in place for the operation to go smoothly. You don't absolutely need to have all three. There is a subset of patients in whom, no matter how much amnestic you give them, they still remember the operation, which is very unpleasant. They remember people talking about them, doing the operation, seeing what they see on the inside. Now, they're paralyzed, so they can't move, and they're usually they have good analgesia, meaning they don't feel the pain. So they're not actively feeling the pain of the operation, but they are awake. And when they wake up, they're really, really unhappy for obvious reasons. This leads to massive lawsuits and a great deal of embarrassment. And what we've figured out over time is that if they're not moving and they're not telling us anything, it's very hard for us to know if they're awake. Now, this led to the development of some tools to prevent this from happening in the future, because this is not what we want to have done to patients who are having an operation, right? I mean, this is not acceptable practice of medicine. And so two companies basically developed two sorts of monitors to try and deal with this. And they both basically take a mini EEG. So what they do is they take a 4-lead EEG on your frontal lobe, and then they take this data, and what they did is they processed it through thousands and thousands of patients. They used a Fourier transformation. I don't want to go through the math of this, but they essentially are able to detect which brain waves are associated with wakefulness, which brain waves are associated with being asleep, or at least being at a point where you don't remember what's happening and you're fully amnestic. And by doing this, and because physicians are busy, we'd like to keep things simple, this is then further developed into a single integer. So all this data is then put together in a large big data algorithm, and you get a number. And the number is 0 to 100, which is easy to remember, keeps it simple for people. And if you're above 50, you're awake, and if you're below 50, you're asleep. And it's not that if you hit 51, you're awake, and 49, you're asleep. It's a range. And we try to keep people consistently under 50, because that is a place where we can reliably say someone is amnestized. They don't remember anything, they don't come out of the operation. Whether these devices work perfectly is a separate issue altogether. And for those people who are really worried about this, you try and keep people under 25. Now, you could say, well, you know what you guys could do is you could just give someone an enormous slug of some drug and keep them asleep, and you would never have this problem. That's true, but then at the end of the operation, they don't wake up. And that's a big problem, because they don't breathe either. So you have to leave them on a ventilator, and so it doesn't make for a same-day surgery, and you have to keep them in the hospital for a couple of days. So there is a Goldilocks phenomenon of getting someone adequately sleepy, adequately anesthetized, but not too much. And these devices help do that. So we started deploying these devices in the intensive care unit. And the reason why is because when you're an ICU physician, when you work in the intensive care unit, you see a lot of people die. Right? So half your job is working as hard as you can to take people who could live and making sure they do live to make sure everything goes right. But we fail a lot, right? Everyone dies eventually, and they usually end up in my ICU before they pass. Not everyone, but a lot of people. So we spend an enormous amount of time with families, talking to them about their loved one and how much is enough, and are we going to basically say at this point, we're not going to do this anymore. Now, what's really interesting and not surprising, but you can spend 5, 6 days, 5 weeks with the family giving perfect care. But if their loved one has a bad death at the very end, that's all they remember. Now, we sort of say, but we gave them great care. The care was great. But all the families in the room, you stop all the medication, and then they have a seizure, or they do something abrupt, or they're clearly in pain. People remember that. And you would too, if it was your loved one. And it's not okay. So in order to try and be better at this and not have a miserable experience for everyone and make sure people die with dignity, we started deploying these devices in the ICU. And the rationale is, well, if Mr. Jones is going to pass away in a dignified way, let's make sure he's asleep. We don't want him to wake up or suddenly be partially awake as he's feeling the process of dying. And we said, okay, we need to get this person sleepier. We gave them sleepier, and then their pulse goes to 0, their EKG goes to 0, and then we see this. And then it goes to isoelectric. And there's countless examples of this, and in the interest of time, I won't take you through over and over and over again because I have more data to show you. And so people ask the question, this is not real, it must be artifact, this is something else. And so we looked at the literature, and sure enough, if you have certain devices in the room, they can interfere with these devices, there's interference, there's lots of devices in an ICU that can cause electrical interference. So we systematically took everything out of the room. So we got to the point where the only thing in the room was the physicians, the family, the nurses, the patient, and the device. And then we still continued to see this. And so we reported this, and we basically said, we're not sure what this is, but it's real. And in one patient, we were able to download the raw EEG, and it wasn't artifact. It's actually high-frequency material. And so what we saw in this initial case series is a rapid upstroke with a rapid decay. It's about 60 to 120 seconds in our first report, and to the degree that we could tell from this initial report, it was real. And we reported it and kind of went on with the rest of our lives because we thought it was interesting, we thought it had some value. It created a firestorm, which was unanticipated, but we'll get to that in a moment. So, the question really is that, what is this? Well, people didn't believe our report, and then David Young's group demonstrated it, and they show something extremely similar. And interestingly, Stewart's seen it in his clinical practice. So this is real. We see it over and over and over again. And then something really interesting happened. So a question came up about animals and how we kill animals in experiments. So it turns out that the way you kill an animal in an animal lab most of the time is through this process. Now, why Coco Chanel has a guillotine made, I'm not entirely clear. This is one for humans. This is what one looks like for mice. So the question was asked to a Dutch research group, is killing mice with a guillotine ethical? Now, I take care of humans, I don't take care of mice. This would never occur to me to do something. But anyway, they were compelled to prove to their animal ethics board that their process was ethical. So they did a study where they systematically guillotined mice with EEG monitors, right? You wouldn't do this as an experiment to see what happens. And this is what you find. The guillotine is the red line coming across, there's some artifact, and then you see an isoelectric. Now, my suspicion is the postdoc got lazy and left the electrodes on, and this is what you see if you leave them on at right about 60 seconds, which is highly consistent with what we saw in people. So we thought, hey, that's interesting. If mice do it, right, and this is repeatable, they've done this many times, and Jimo Boringin's group has done this in a highly systematic way in 2 reports, and what they show, and I think this is a really important thing to read, high-frequency neurophysiologic activity in the near-death state exceeded levels found in wakefulness. Now, these are in animals where they have basically leads that are on the brain, some that are subcortical, reading it, and you have cohesive activity in animals after they're dead. This is what wakefulness looks like, this is what deep anesthesia looks like, and this is what they look like when they're dead. So this is real, it's in humans, it's in animals, it's highly repeatable, it happens all the time. So the summary of the current state of the literature and data are as follows. There are surges of EEGs in certainly animals, meaning mice and rats that we can prove, and they're in humans. And if you pull the raw EEG, it's there. This is not artifact. The reproducibility is important because in science, if we can't reproduce it, we don't believe it. This is highly reproducible. And now I get phone calls from people all over the country and all over the world saying, oh, Mrs. Jones passed away. I saw this big spike. You know, you guys were right after all. Now, the issue of coherence is important. And now the story gets slightly more complicated. I'll show you our new report that was just published around 6 months ago, and then we can discuss what it means or doesn't mean. But the initial hypothesis that we offered was this is the brain kind of having a seizure, right? It has no oxygen. It's just sort of out of luck. And in this process of dying, it, in some occasions, forms a wave. There's a notion of spreading depolarization which can occur, happens in strokes, happens in other maladaptive states, and we thought this might happen. But this EEG waveform activity is non-seizure. This is not seizure activity. This is not someone having a tonic-clonic event after they have no perfusion. This is something very different. So there was a few, there's many remaining questions, but there was a few that we thought we could tackle. One is, does this occur in everybody? Because if this is a preserved physiologic state, meaning that your brain is dead, it has a survival mechanism, this is a last gasp mechanism to reboot the brain, that kind of makes sense. That's teleological. There's an evolutionary rationale for that. Maybe one last gasp to try and save yourself or do something to block or deal with whatever is attacking or killing you. That makes sense. Well, if that's the case, it should be very frequent. You should see it in 80, 95% of people. Or it could be a really rare phenomenon, right? It's just things lining up in the, you know, in the holes of Swiss cheese that a rare event happens, and then you'd expect it to be a really low incidence rate. Now, we reported 7 that we had seen, but we never systematically assessed this, and that's what we tried to do, because we know that there are people like this. This is a patient I was in the room for. She was a 75-year-old teacher. She had metastatic cancer. All her family had passed away. Her daughter couldn't travel to be with her, and she asked that the ICU team be in the room when she passed away. And we said, of course we will be. We sat in the room, me and one of our really outstanding ICU nurses, and we felt like we had the duty to be the family. We sat with her, we held her hand, we gave her extremely high doses of narcotics, we pulled the endotracheal tube out, she stopped breathing, the pulse goes to 0, EKG goes flat, and then you see this massive spike of activity, and she's not moving. We're in the room, and then it goes to isoelectric. But we also see this. There's another patient I was in the room for, and this is what you'd expect. You die, there's no oxygen, brain function rapidly drops off to 0. So how many times do you see this, and how many times do you see this? So that's the question of the study that we did. And what we basically did is we serially took every single patient who was in palliative care who had a device on them, and then we went back and we pulled the data from the devices because the devices actually keep the data. There's an archive. And so what we would do is every morning we would come in, or actually we did it weekly, we'd come into the ICU and we'd say, did anyone pass away in the palliative care protocol? Yes. You know, Mr. Davis in room, blah, blah, blah. We'd go in, did they use the protocol with the device? Yes. We would take the device down, we would download it and see if it happened. And this way there was no bias. Because when you're trying to report something that happens, there's bias, because you want to show it. You're like, there it is, there it is, there it is, there it is. So we said we need to take the bias away. We need to know because what we're actually trying to understand to the degree that we can in a small samples, what is the incidence of this? How often does this occur? And so what we did is we tried to be as systematic as we could in a field that is being made up by us and others as we go, because no one really studies death in humans. And we said, okay, we're going to look at the peak and the baseline, we're going to do the duration, we're going to do a really simple but hopefully repeatable descriptive study. And whether the peak or the baseline are meaningful to you, the question that I always get is, okay, if there's a spike, how long is it? And how long does it take for it to start? So the answer to that question is in our hands in 35 patients and 28 of whom who have spikes, what you find is that the delay is around 60 to 120 seconds before you get it. And when you do have it, it can last usually in the vicinity of something like 2 minutes, 3 minutes is the usual. But you can see that the mean duration was higher than we expected. And it's got a pretty big standard deviation. So some people have a pretty sustained spike. Now, this is an example of someone who didn't have a spike, right? So basically, we pulled the endotracheal tube. You see the immediate drop-off, top the blood pressure medication, and then they rapidly pass. And there is no spike here. Now, if you look at arrow 1, this is what the EEG looks like. This is the raw EEG from the device. So arrow 1, the device says the algorithm, the patient is awake. The frontal lobe EEG has sufficient activity to justify that. This is arrow 2. You can see highly agonal, no architecture, moving to isoelectric. And at arrow 3, you expect what you'd see, which is someone who's passed away, no brain activity, their EEG is isoelectric. This is another patient who had a very robust spike. And as you can see at arrow 1, after their initial drop-off, after their initial beginning of pulselessness, they have an isoelectric EEG. And then at arrow 2, this is what you see. This is the raw EEG. This is not processed. This is not artifact. This is the raw EEG. Now, we did not systematically do this, that I can tell you what the alpha, theta, and gamma coherence is. This study was not designed to do that, but I can assure you this is the actual EEG. This is not artifact, people. This is very real. And then it goes to an isoelectric state. So the main take-home point from this is that fundamentally we're at the point where we can say that this entire process that we're seeing is real. It's 35 patients, and one of the most important things we wanted to do was demonstrate this does not occur in patients who are brain dead. And the reason why this is important is that brain death is the mechanism by which almost all transplantation and donation occurs in the world. And I'll explain what I mean by that and why it's important. So before we had transplantation, when you died, there was no rush ever to be dead. You could wait a day, you could wait a week, you could wait a month. I mean, there was some serious house cleaning involved, but it didn't really matter. But the law in the US states that when you're brain dead, you're dead. So if you are on a motorcycle driving 110 miles per hour and you decide to do a wheelie and you end up basically having isolated brain injury, you come into my ICU. This happens all too frequently, by the way. The rest of the body from the neck down is perfectly intact. Their brain is dead. That person is declared dead through a very formal process where you test the brain, you image it. There's a bunch of checklists you have to do. But one of the keys is you declare them brain dead. Once you're brain dead, that's your birth certificate that moment, that day. Your heart's still beating, the rest of your body's perfusing, but you are dead at that moment. The reason why that's important is once you're dead, your family can then donate your organs if they so choose, because it's okay to take the organ of someone who's dead. This is really important because if people who are brain dead are spiking, then there's a major ethical quandary that we would have to potentially deal with. So that's not happening. That's important. And one of the things that's very important for me as an intensive care physician is not to undermine a really important transplantation process that occurs throughout the world, because these people die if they don't get organs. So this was important. Of the remaining patients, which is 28, about half showed a spike. Now, I don't think we can infer too much from this, but it's not the frequency I expected. I expected either 90% or 10%. I don't know what that means, but it's not what I expected. And not all patients have spikes, which we've already mentioned. And the implications for organ donation for brain death, I don't think we have to worry about, because no one with brain death actually spiked. But there's another group of patients who donate organs called DCD. And this is donation after cardiac death. And the reason we do this is because there remains a shortage of organs in the world. And so in order to deal ethically with the process, what we do is as follows. So imagine you have a loved one who is terminally ill, and everyone decides that Dad wouldn't want to have this anymore. So we say, okay. So what we do is we take them down to the operating room, and then we withdraw all life support. And then we wait, and if they are dead, and meaning that they are pulseless and they can be declared dead, within a certain amount of time, we then immediately harvest their organs because they still haven't had time to be profoundly ischemic and hypoxic, and they can be transplanted. Now, this is for anyone who's never been a part of this as a physician, the first time you do a DCD, it's very scary because they ask you, when you're sitting there behind the curtain with the patient, to say the patient's dead. Because as soon as the patient's dead, the surgeons dive in. Because the time to get those organs out, get them in a reperfusion machine is critical for those organs to work. Well, you don't want to be late, but you don't want to be too early. Right? I mean, you want to get this just right. Now, you have a bunch of surgeons on one side. Everyone feels for the patient. The patient is dying. This is not a great thing, but we're also trying to get their organs. So how do you manage this? Well, very carefully, right? Now, the problem in the DCD world is that if you have no pulse and your EKG is flat, are you dead? Or are you dead after you have a brain spike? This is a problem. And this is an ongoing issue, an ongoing debate. Because if it is true, and I don't think it is, for the record, but if it is true that the boundary between life and death is a spike, then the people who believe that are asking to wait another 2 to 5 minutes before you go on with organ procurement. 5 minutes of more ischemia means a much lower likelihood that the organ is going to work in the person who's receiving it. Now, that may not seem like a big deal, but if you're receiving the organ or if it's your loved one, it is a big deal. Because that organ is going to be substantially more compromised. I don't think that this spike has anything to do with whether you're alive or dead. I think this is an independent event that's happening in the person's brain. But whether we can prove that or not is a separate issue. So this is an issue that we need to deal with. So there are significant implications for transplantation, not for brain death, but for DCD. And I promise I will get to how this is relevant to consciousness in a moment, because I think it's extremely relevant to it. But the other big issue that's come up as a consequence of this is the notion of near-death experiences. Now, this is an extraordinarily volatile, third-rail type topic that I'm not going to get into in any significant detail. But there are basically people who believe it and people who don't. And, you know, there's a lot of snickering about this. And what's interesting is when you work in intensive care is many patients have these. They're very afraid to talk about them. They're afraid to get made fun of. And the one thing I will tell you, having published the first series, and I've gotten over 100 letters from people who have had something happen to them. And I'll tell you one thing which is for certain. All of them say the same thing. It remains one of the most meaningful events of their life. It ranks up there with the birth of their children or getting married. So I don't know what it is. I don't know if these spikes are those. But whatever this is, if it results in a near-death experience, it's extremely meaningful to the patient. And if the patient is you and it's meaningful to you, it's meaningful. And I think that we have to disentangle ourselves from our preconceived notion of what things mean and study it. I think we should just be thoughtful about how we study it. So I gave an interview to a Irish radio show, and I scientifically explained all the information I just explained to you, and I was berated for not understanding that the soul was clearly leaving the body, and us stupid physicians are so scientific, we have failed to see the divinity. And this is common. And Stuart Hamerhoff and Deepak Chopra have offered a possible rationale for this called the quantum soul, which basically relates to the energy of what the brain does when it dies. And I'm not going to take you through this lovely chapter they put together, but I highly suggest you read it. I think it's fascinating, and I think it's very engaging. But I think it's important because it leads to some other important questions, which is that I don't know what these are. Let's just start with that. But the beginning of all knowledge, in my view, is I don't know. I think it's a really important question. So my initial hypothesis is this is a cascade of dying neurons. The neurons are dying, they're all interlinked, they still have some energy from the sodium, potassium, ATPase, and they can discharge that energy. Maybe they discharge it in unison. Maybe it's adaptive, maybe it's maladaptive. It kind of doesn't make a difference, and it could be a form of spreading depolarization, which is a well-characterized phenomenon. And that could generate a lot of energy. The thing which is striking, and this is what Deepak said to me, he said, you know, Mink, if you're suggesting that this is spreading depolarization or ischemia, it makes it very hard to explain cohesion. I think that's a fair point. So I think this is a very astute observation that a dying brain that's doing something in extremis ought not to be doing something cohesive. That doesn't make a lot of sense. So we have not reconciled this. I think this is part of what we need to explain moving forward. I would say to you that what you think this spike means depends very much on where you start in your belief structure. So if you're an atheist versus someone who believes in God and are deeply spiritual or somewhere in between, will massively inform what this is. So what the atheists say, and by the way, atheism, like true atheism, not sort of like agnosism, you know. Being agnostic is, you know, no big deal. True atheism is exhausting, right? Because you have to actively fight every religion all the time and every belief. I don't know if you've met some of these people. They're exhausting to be around. I mean, like, it's them and the nihilists. It's like, guys, you guys need to have your own, like, event. And please don't invite me, because I'm not coming. But the atheists are like, this explains the one thing we couldn't explain. All these people kind of die, and they come back, and they remember seeing God, and it's not God, it's this spike. And Mink, you've given us the rationale to debunk all the near-death experiences everybody has. And I'm like, that was not the plan, guys. So that's what they think. People who have a deep belief in God are like, this is the soul. I mean, we've been looking for the soul our whole lives, there it is. And you're just blowing it off. So depending on where you start, depends on what you think this means. Same data, this is what I love, same data, totally opposite conclusion, right? And, you know, the answer is we still don't know, but I think that before you make an interpretation, okay, consider what your pretest probability was and what it meant to you before you interpret it. I think it's really important that you do that because we all bring bias to the table. The only thing I can say definitively is there's a few good things about spending a lot of time around people who are dying. One of them, it is the best remedy for affluenza. You know, I don't think about why I don't have the newest iPhone. I don't worry about why I can't get a seat at a certain restaurant or if they're out of a certain fish that it's a problem for me that evening, right? It makes it hard to come home sometimes and hear my children complain about nonsense. After you've spent, you know, 3 hours with a dying family with, you know, their child who's, you know, in their 20s, right? It leads to comments at home when my kids say, what are we doing this weekend? I said, we're going to go to a mud hut in Mogadishu for a weekend, and we're going to spend time with a warlord so you guys can stop complaining. My wife is deeply unamused with those comments, by the way. That's neither here nor there. But the one thing I will tell you is that when you tell a family that their loved one is dying, and you can show them evidence that something, I don't know what it is, but something happens when you die to many people, it is stunningly comforting. No matter what their belief is, from atheism to deep believers in a deep religion or spirituality, it gives people some solace that there may be something else. I'm not saying it does, but it's been incredible to me that just knowing this, what it does for people who are with their loved ones when they pass away. And if you're not in that moment, not in that space, it's hard to appreciate, but I assure you, when you're in that moment in space, you'll remember this. So what is it? I think that whatever this elephant is, this is what we are at. We got a tail, and we're like, there's a tail of something. So why is this important for future research in consciousness? Well, it's as follows. We're going to continue to do research in this space, and I think one of the primary things we're going to do is we're going to better characterize this. First, we're not going to make any conclusions. We're going to further characterize it. And the plan is altruism. And you must be thinking to yourself, what is he talking about? Now, being a clinical investigator and taking care of patients and enrolling them in clinical trials, I have been deeply moved by how altruistic people are. And I'll tell you a story of a young teacher who I took care of in Washington, D.C. So we were running a clinical trial. He's HIV positive, but he's extremely well controlled on 3 drugs, and his viral load is 0. He's undetectable. And so he qualifies for the trial, and the drug that's being given has never been given to a human before. So this is first in man. He would be the first human to ever get the drug. It's been given to hundreds and hundreds of animals with no problem, but he would be the first person. So I call his ID doctor, who was the guy who actually trained me, and I said, hey, Doug, you know, your patient qualifies for the study, but he's HIV positive and it's first in man. I don't know, what do you think? He's like, well, you should give it to him. I'm like, I don't know, Doug, I'm probably not going to. He's HIV positive. And he said to me, Meg, why are you discriminating against him because he's HIV positive? I'm like, I'm not discriminating, Doug. Look at me, I'm underrepresented as a minority. He's like, yeah, you are. He goes, because if he wasn't HIV positive, you wouldn't be calling me, you'd be consenting him. He goes, he's immunologically intact. His viral load is 0, his CD4 count is normal. What's the problem? Fair point. Got reasonably humiliated. Went to the patient and I said, Mr. Jones, here's the deal. This is a drug that could help you, but it's never been in anybody, and we don't know. And he said, I'm the first person ever to get this. I'm like, yeah, pretty much. He said, I'll do it. And there's a reason he did it. And the reason he did it is because he knows there's thousands and thousands of men and women who took HIV drugs in an experimental phase 25 years ago who died. It didn't work for them, but that's why he's alive and well today. And this kind of story happens all the time when you take care of patients. They're incredibly altruistic, and so there are opportunities to say to people, you have a terminal illness. We want to do something non-invasive, non-painful, but we want to study what happens when you die. And everyone says, oh, they won't do it, foundations won't do it. People will do it. You won't get everybody, but people will do it. So there will be opportunities to do this. The larger question is what to measure. So I showed these data when I was in Stockholm at this meeting. Stuart, how long ago was that? 4 years ago? 6, oh my God. Okay, that's distressing, 6 years ago. And I was showing these data to Roger Penrose, and he made a really thoughtful point. He said, don't be limited in your degrees of freedom on the energy you measure. EEG is but one form of energy. It's electrical energy, but there's lots of forms of energy. That was a really good point. I don't know how to solve for it, but it's something we're working on. So in conclusion, these are common. They happen in people. They happen in at least small mammals. My hypothesis is that as the mammal's brain gets larger, the higher the frequency they can generate. It's probably a combination of the ability of energy to create it and some form of mass. We don't know what these mean, but what I would say to you is that there is an opportunity to study consciousness in this space, and here's why. When you die, whatever that individual's consciousness is in that moment dissipates in some way. And in clinical medicine, we have come to learn and understand that one of the best ways to learn about someone's disease process is by stressing them. So if you have heart disease, and I'm looking at you, you're sitting at your chair, it's really hard for me to determine if you have a critical lesion or not. But if I put you on a treadmill, I'll figure it out pretty fast, and you'll tell me. Or your EKG will tell me pretty quickly. So when you stress a system, when you perturb it, when you take a particle and you crash it into another particle, whether this is mass spec, whether this is a particle collider, you create more information in that event. So acute dissipation of your consciousness, i.e. death, may be a very good opportunity to see in that decay what's going on, because that decay may actually tell us a little bit about what consciousness is or is not. Because once it dissipates, it should give off something as it dissipates. This is the way we do MRI. We excite protons and spin, and then we take the excitation away and we look at the decay. So we do this throughout medicine. And if you think of consciousness in an incredibly simplistic way, because that's the only way that I'll really understand it, because much of what you guys are doing is above my head. I'm just a clinician. But I do know that when you stress the system, you often learn more. And I think arguably something more stressful than death. And with that, I will stop, and I'm happy to take questions. Thank you.
Thanks, Meg. Thank you very much. Over there.
Thank you very much. Amazing work, both in its interpersonal sensitivity and its scientific rigor and openness. Thank you. I just wondered if you'd thought about adding a computational neuroscience element to your research program, because ever since Hodgkin-Huxley, basically, one way that we've been able to understand the complex dynamics of nervous system is by mathematical modeling, and one way that you might be able to explore the various theses that you have about what that discharge, that spike is, might be via various forms of modeling.
Yeah. So I think that's a great point, and I think that there's a couple of ways to solve for this. Since it happens in animals, you could, I feel terrible even saying this because it feels awful. PETA people are probably like, immediately like tracking me, but if you in a controlled environment had sacrifice. Now the way to do this is all these animals and all these big animal studies get killed anyway. So you could just take advantage of that opportunity, especially in the control animals, and see what that dissipation looks like. I think you could model it. And what would be very nice is to have a model and then see what we'd expect to see in the human and then try and validate that and see if it shows up. And looking at different energy forms, whether it's EM, whether it's EEG, or some of this other really interesting stuff people are suggesting, that can all be looked at. The key is that this is not going to get done by our group exclusively. This needs to be a concerted effort, and there needs a place where we can have a forum where we look at this, and maybe this meeting or something related to it, but I think it's an opportunity.
Way in the back.
Hi, thank you. Great presentation. Two quick questions. One, if the prevalence in human beings was about 50% of having these spikes, what was the prevalence in rats and mice? Was it the same? The other is, did you check to see if there's any correlation with the patient's spiritual beliefs and whether they had the spikes or not?
Yeah, so for the animals, it tends to be more frequent, but those animals are all getting killed in a very controlled environment. These patients are dying of some disease. Some have stroke, some have tumors. All of them are on some form of sedation, so there's some issue there. Also recognize that, we did not do this in a highly rigorous experimental way. This is, convenience sample data, so I think the incidence that we demonstrate is probably less than the actual. As far as spiritual beliefs, no. And I'll be honest with you, we've had the problem in our ICU of having a person come in who's passing away, and you make some impression about who they are, and you all look through their monitor, and you make an assumption about what it means and what it means for that person. And I think that's deeply problematic, right? Because in the experience we had a very religious family. The nurse was very religious, told them that people have these spikes all the time. The patient didn't. There was an expectation of what that meant or didn't mean. That was not an optimal afternoon at the office, right? And it's not exactly one that we get trained to deal with, because the question fundamentally was, well, how come my mom's soul didn't rise? I'm like, and I really, that's why I think it's really important that we don't start with a preconceived notion of what it is or isn't.
Yeah.
I'm wondering if you could do an experiment to look at the balance between inhibition and excitation in a dying brain when you get into a hypoxic state, and see if it's a matter of disinhibition of the inhibitory neurons, cortical, kicking in first that allows the coherent spike and all the rest. And you could do that in vitro or possibly in an animal model.
So for a human, could you do that under MRI? Like what's the kind of sensors you need in place to do that kind of experiment?
Well, in an animal model, you'd probably want to have electrodes that were selectively looking at both excitatory and inhibitory neurons.
Would they need to be on the surface of the brain, or could they be on the scalp?
That's a good question. I don't know.
Because if it can be on the scalp and it's not invasive, we can do it in people. That's the reason I'm asking the question. If it's on the surface of the brain, that's a little more problematic.
Yeah, for sure in the animal model you could do that that way if you don't mind using animals that way. That's a problem for some of us. But in vitro, possibly, if you had some brain tissue from somebody who just passed that was still intact, which is probably a long shot, I suppose.
Well, what's very interesting is that they have actually looked at people who have recently passed away and actually passed electrical activity through a freshly dead brain, and the circuitry remains very coherent, intact, which I found amazing. I mean, this has been repeated a couple of times. And how long that stays intact, I think, is unknown. So that could be an interesting place. But what I would say from the animal study standpoint is thousands, if not hundreds of thousands of animals in placebo arms of trials get sacrificed every year, right? Because for every trial you do, you have a sham. So I think that if you looked at that as an opportunity for animals who were being killed anyway, you might have that opportunity.
Let's go back over here, gentlemen in yellow, and then back over here.
With regard to the NDE, I read reports from people who back up the NDE experience as being spiritual, that this spike is probably when it's taking place, their private NDE experience. But I see a problem with that because an NDE must be reportable. And from what you're saying, after the spike, there's no reporting.
Not in our series.
Okay.
But I think that I think designing an experiment to correlate the spike with a true NDE is very problematic, because the question fundamentally, and this is not, this is going to sound like a joke, but it's not, but what is near death? I mean, you nearly get hit by a car, that's a near-death experience. Being on a plane that lost power, that lands in the Hudson, that's a near-death experience. People have events when they're scared and terrified and stressed. People who go to the operating room have had big procedures, report stuff, but they were never, ever hypoxemic.
Well, it's
they
usually
never lost their pulse.
It's usually post-cardiac, I believe, though. It's post-cardiac arrest.
Sure, but I think that the issue is then how do you fundamentally characterize it? I think that there's opportunities there to look at that, but I think the judgment on what an NDE is or isn't is problematic. I do think, however, that it is a plausible explanation for many of these. That's, and I would go only as far as that, but it has not been subjected to adequate rigor.
Since I'm not a medical person, hence this ignorance and the question, that the EEG tracks the electrical activity in the brain area, but the brain is connected to the spinal cord, and so is it possible that this activity actually arises in any of the ganglia, from any of the ganglia in the spinal cord?
I would say we don't know, because the 4 leads that we had for this device are only on the frontal lobe. I think the first simple study to do is to do an appropriate 24-lead EEG with high fidelity. Start with, what we would call low-hanging fruit, and actually just see, is it anterior, posterior, is it global? I just start with something simple like that. I do think if we generated collectively enough interest in studying death thoughtfully, you would have people with terminal disease who'd be willing to die in an MRI scanner.
So it could be posterior in some people that you're not picking up. So the ones who don't have it could be posterior.
So coming back to the more mechanistic interpretation of what you report, the one thing you emphasize a lot is the coherence of the response. But unfortunately, you didn't analyze it further, so we don't really know which frequency bands this is playing out. But have you analyzed this from the perspective of the thalamocortical system? Because I think this would be a very beautiful candidate for exactly this phenomenon. Because if you would have, let's say, a more global hyperpolarization of your thalamic cells, they switch into regular bursting mode in, let's say, around low alpha or high delta, which would exactly give you sort of a high energy and also strongly coherent response that will spread through the thalamocortical network. So I think that's a range to look at, and you have also already a number of good models of that have great validity with respect to a number of pathologies.
I think that's exactly right, and that will be what we would want to try and at least look at with a full 24-lead EEG, is that does it stay in one place? Is it global? Does it move around? It could be a spreading phenomenon before the brain technically runs out of energy. I think all of these things are extraordinarily interesting, and I was very clear about the limits of the data, but the overwhelming other data in animals definitively show coherence. So that, to me, is really remarkable, and we're going to obviously work hard to try and get more data, and hopefully we'll have something to show everyone soon.
Good. Rutherford, yeah.
I just wondered if you were aware of the work of Dr. Annie Sauvageau in Canada. She's a forensic pathologist who has the largest collection of videos of people who have hanged themselves in the world. And this is sort of an unintended experiment, and she observes that within about 8 to 18 seconds of full suspension, people lose consciousness, and then within seconds after that they convulse, and within 30 to 60 seconds they exhibit decerebrate posturing, and then sometime after that they exhibit decorticate posturing. And to all intents and purposes, watching the videos, they're somatically dead within 2.5 to 4.5 minutes. And these are people not quite like yours who may have been sedated, paralyzed and so on, but who choose to hang themselves. But it seems to me there's a parallel between what you observe and what she observes. We know that these people don't die from asphyxia. We can hear them breathing, and that it's carotid artery pressure resulting in cerebral ischemia. So something happens in the way of convulsive movement, decorticate, decerebrate posturing in this period, which might correlate with the electroencephalographic findings that you see.
Yeah, no, that's interesting. I was unaware of that. It might be an opportunity to try and line up timelines. There's obviously some confounders in case they sustain any spinal injury during the event. But I think that given the number of placebo animals that are routinely killed, I think that's a very easy place to start by just saying, look, you finish your experiment on these, 85 guinea pigs. Do you mind if we put some EEG leads on them as, you do whatever you do to kill them? I think that's a good place to start. I think for the human experience, the key to getting this right is getting the ethics right, in my view. And I would pretty much insist on patients consenting for themselves. And I think the only opportunity, and maybe there's others I haven't considered, is in hospice environment for people who are cognitively intact but are suffering from some other ailment that leads them to be terminally ill. So that's the approach we're currently taking, and we want to get full buy-in from their caregivers, their family, and the patient. This is a slow, thoughtful process, but we think if we get high-fidelity data, we can hopefully then inform the community, and we can maybe do some other thoughtful experiments.
Thank you.
One more over here.
Oh, thanks for the very nice talk. So there was a study called the Awareness During Resuscitation study. Are you aware of that?
I haven't read it, but I'm aware that it was done.
So yeah, this is followed over 2,000 people who were resuscitated from cardiac arrest. Not all of them survived, obviously, but the ones that did, there's a lot of congruence between your findings and their findings. So only about 9% reported like full-blown near-death experiences, according to whatever classification system they had, but 46% reported some sort of cognitive activity while they were under cardiac arrest, which matches your finding of, I think, 43% having that spike.
Well, that's interesting. I was unaware of that proportion.
Yeah.
Well, so thank you for that. I was unaware of that, and I think the take-home message is that there's a lot of information that's out there that we need to aggregate, and that's something I'll certainly look at as well to see if we can glean anything from it moving forward.
All right, then let's thank Dr. Chawla and all three speakers.